So what we'd like to do here is just work through a couple of problems where we have forces pulling in different directions on an object which is in equilibrium. Now when we say it's in equilibrium, we mean that it's not accelerating, that the net force on it is zero. So all the forces are balanced. And so we're going to practice calculating one of those forces or more when it is in balance. Okay? So the first question here is dealing with a tent that's tied by two ropes to the trees. So if I visualize what's happening here, right? I've got the tent, it's sitting on the ground, and then the edges are kind of tied up to some trees here, right? Okay. Of course, we've got the big old bear that's sitting here right in the woods. There's his teeth. He's getting ready to come eat the campers. But that doesn't really affect the problem, does it? But so that's what's happening. So if I draw my free body diagram, that is my tent. I've got one rope pulling up on the tent in this direction, and I've got one rope pulling up in this direction. Now I know that angle right there is 57 degrees above the horizontal. The only other things that are pushing on my tent is we've got the ground, right? The normal force is pushing up on the tent, and then we've got the force of gravity pulling down, right? And since the ropes and the ground are the only thing touching the tent, those are my only three contact forces, and then I've got the force of gravity that's pulling down. Okay? So if I write equations for this, I can write an overall equation that takes the normal force plus the force of rope 1 plus the force of rope 2 plus the force of gravity and adds them all together, and that should equal 0 since the tent is not accelerating. Or I can take it in the y direction and take each of those pieces in the y direction, or I can do it in the x direction. Now the normal force and the gravity force don't have x components, but these two do. Okay, so what I'm going to do is I'm going to take the y components of each of these, okay, the up and down, and we're going to create an equation for that, and we're going to solve for how much force is exerted on the ropes in the vertical direction. Okay, so what we'll need to start to do is we know that the mass of the tent is 12 kilograms. Well, I know that my weight is equal to the mass times gravity, the gravitational pull. So the weight is the same thing as the force of gravity. That's what it is by definition, times 12 kilograms, and then times negative 9.81 meters per second squared. And if I do that, then I get 117. So the force of gravity is equal to negative 117.72. Now all the negative means is that it's going down, right? We know that the normal force, it told me right here, is 60 newtons. Okay, so since I'm doing the y components here, I can just say, okay, well, 60 newtons, which is the normal force, and this is in newtons as well, plus the force of rope 1, plus the force of rope 2, plus the force of gravity, which is negative 117.72 newtons, equals 0. And so from here, the algebra is pretty easy, right? I'll add the 117 to the other side, subtract the 60, which then will give me that the force of rope 1 plus the force of rope 2, force of rope 2 is equal to 57.72 newtons. Now it told me that I'm assuming that the force is distributed evenly upon the two ropes. So since there's two ropes, that means that if I add these two together and get that, that means that these being the same, then all I need to do is half this. And so I'll go ahead and divide it by 2. And so the force of one of those ropes, now again this is in the y direction, right? Everything was in the y direction, is going to be equal to 28.86 newtons. Okay, so that's in the y direction. And so to finish off the problem, I know that the force on both the ropes is going to be the same. So if I take that and I draw that was 57 degrees. So now I'm actually going to use that angle. I know that the force in the y direction has to be 28.86 newtons. Okay, I do have an x component there as well, but it looks like I need the opposite over the hypotenuse. So sine of 57 is equal to the opposite, 28.86 newtons, divided by the hypotenuse, or x. That's what I'm looking for. So I'll multiply both sides by x, which will get rid of the x over here, and then I will divide by sine of 57, so x equals 28.86 newtons divided by the sine of 57. And if I do that, then I get that the total force is 34.4 newtons. And so that is the force on the total force on each of the ropes. That would be this right here. And that's the answer. Okay? So I'll go ahead and stop this one. If you want to see another example, feel free to watch the second video.